was a 1. Okay? Now, do you remember, we did this a while ago, a grouping, when we were factoring polynomials, that if these two were the same thing, I could say x squared minus 1 is, this is times x plus 3, and this is times x plus 3. So, since they're both being multiplied by x plus 3, I can combine these and have x squared minus 1 times x plus 3 equals 0. Okay? And, you know, as I said, when I did this problem, I kind of had to really think about it, so I can appreciate it if you were stuck on that. What kind of a, what do I know about this? Does this have a special name? When I'm factoring, something about that has a special name. Anybody remember? Is this a perfect square? Well, it's not a trinomial. Is this a perfect square?
No.
1
Negative.
is, what do we, had we learned, how about this one? About x squared minus 9. What are the factors of x squared minus 9?
3.
X and 3.
X plus 3, x minus 3. Is this the difference of perfect squares?
Yeah.
Okay, do you remember? Tell me yes.
Well,
Okay.
we all know that, we learned it just like.
Okay, well, it needs to be in your little booklet, and hopefully that you can go back and refresh your memory. Because is this the difference of perfect squares? Okay, so if I know that this is the difference of perfect squares, what do I know my, what will x have to equal here?
Negative 3.
This is, well, I just did this, I was hoping that this might jump out at you. So this is gonna be what, x minus 1, x plus 1 equals 0. So x is going to equal a positive 1 and a negative 1. Okay, and then I have x is going to equal a negative 3. So that one was an oddball one. I'm not going to be asking you to do those. I mean, and this is a good one for us to do as a class and to refresh your memory of the difference of perfect squares. Does that ring a bell? Yes, no? I mean, you've heard of these things before? Heard of them. How many people have no recollection of the difference of perfect squares? It's okay, raise your hand. No
I
recollection.
remember learning it, but I don't remember.
Yeah.
Okay.
I remember it rings a bell. but-
Okay, so if everybody has their little folder, please get it out and look at it, because you need to kind of, that has to be sort of fresh on your fingertips, not like a distant, oh my gosh, I learned that way long ago.
Well,
Okay.
that was during factoring?
Yep, it was during factoring, and I believe that was in chapter 5. Yes, Steve?
Wasn't that when you had a negative or and a positive 3, and that would equal negative 3 add, negative 3x add 3x, which equals 0,
Right.
and then negative 9.
Right, so, and that's what happens. If I had a plus 3 and a plus 3, when I multiply this out, I have x squared, x is x squared minus 3x plus 3x minus 9. And remember how they cancel, that's what happens, is they cancel out. Okay? You okay with that, Cassie?
Yeah, it's like in the recesses of my brain.
It's in the recesses of your brain.
somewhere in there.
Okay. Okay, so that was number 8. Number 6. Number 6 was a perfect square trinomial. And we took notes on these, and this one, whoops, sorry. The perfect square trinomial, is this a perfect square? X to the 4th. And is 16 a perfect square? Okay, and it happens that they're both negative. I remember we did worksheets of these, and I had you kind of like churn through them. And so I know that I would have x squared minus 16 and x squared plus 1 would give me a negative 15x. And And so I have, x minus 4, x plus 4, and, sorry, this is all. X squared, you have to be careful here, because x squared could equal is a negative 1, and what do I know that this would be? X would be, what kind of a number? An imaginary number would be a I. Right? Okay, so that's what those two would be for factoring. I guess I'm more concerned that you know how to divide. So let's move on. We did the division problems. Anybody have a question on number 10?
Can you have
Think of the
answer?
Yeah, number 10. Can I have a negative remainder? Oh, yeah. Yeah. Number 10, the remainder was a negative 2. Just,
On as well.
hold on. Negative 10. Here it is.
Should we be?
Okay, is everybody okay with that? I'm sorry, what?
Should we be doing it out to get a negative remainder?
Okay, so there are two things that we did. You need to know how to divide. Next year in pre-calc, you will learn how to divide. There's also something called synthetic division. Synthetic meaning what? Fake. Okay, and you will learn another shortcut called synthetic division. But given that this is pretty much based on the division that you should have learned in grade school, you should be able to divide and come up with your remainder. Now I showed you the remainder theorem, which the remainder theorem is if I plug in this case, it would be a negative 3. If I plug it in, I should be able to find the remainder easily. Okay? So, all right, let's just go through the division. So you had problem number 10 to do. Anybody have any questions on that? The answer was a negative 2.
Well, when you multiply by the number on top, and like the 5 and the 3, you get 15. When you
The 15, yeah,
when you switch the signs around,
yeah.
like if it was supposed to be a negative number and it was like a negative 5, would you switch it to a positive?
Yeah, because it's minus some
yeah,
whatever.
That's messed up.
Okay, so in this case, I had a negative, so that was a negative. A negative 2x times x was a negative 2x squared. But then because I'm subtracting a negative, it becomes a positive. And that's what you're trying to do, you're trying to cancel them out.
Right.
Okay? All right, so that was number 10. Number 12, any questions on that? Number 12, the remainder was what, 6? Okay, were you good with that? Cassie, yes, no? Okay, good. Anybody else? Haley, you good with these? Okay. And 14. Okay, let me see, 14, I don't want to look at that. Number 14, 2D. The remainder was a negative 2?
Yeah.
Okay, I have an error in mine. I know that I have an error, and I'll show you why I have an error. Should I have an X here? No, and I didn't have time to go back and find my error, so I just left it with, I know I have a question here, and I meant to go back and fix it. Okay, so I'd like to just quickly go through 16 and 18. It says, find each remainder when the first polynomial is divided. So we are just looking for the remainder. Two ways to do it. You can do the whole thing out, or, anybody? Just plug in, let me see if I have one done here. Plug in. Hold on a second, I'm gonna have to.
practice, has also been canceled for this afternoon, there is no volunteer practice this afternoon.
Watch your eyeballs. Okay, I am giving you a worksheet on a problem on the box. Does anybody have their book open? Sarah, could you check page 563? Because I believe it's on page 563, and it's the pizza box problem. Okay?
You need to bring our books.
No, well, you might want to read the problem because it is 563, the box problem. Okay?
So it's what works, the worksheet you're giving us?
Is a copy of it. So